Hello guys, welcome to Pepcoding, and now we are going to solve the next question, that is minimum stack constant space. Okay, so we have already done the minimum stack in our last video, but the problem was in the last video that was that we have maintained our minimum value with the help of one stack. Okay, so in this question we are going to take the constant space. That is, we are going to maintain our minimum value by using one variable, that is min-val. Okay, so with the help of variable we are going to solve the question. Okay, so let's discuss this. How can we do this? Okay, so let me take one stack, that is our actual stack, data stack, and the next thing which we are going to take is min-val variable. Okay, so the next thing is min-val, and with the help of this variable we are going to maintain our minimum value. Okay, so this is our data and this is our min-val. Okay, so let us perform some operations. So first I'm going to push 10. So this value will be pushed in this stack. So this is our actual stack. And what will be our minimum value? So when the size is 0, then we have to push the 10 in the stack, and then what we have to do, we have to assign 10 as min-val. Okay, so when the stack size is 0, then we directly put this 10 in min-val also. Okay, so let me perform more operation. So suppose we have pushed 20, so 20 will only pushed into the stack. Okay, but our minimum value will remain same because 10 is the smallest number. So if the val, that is the value of this is val. Okay, so we have assigned with val variable. So if the val is greater than min val, we only have to push it into the stack. Okay, the value of min val will not be changed. Okay, so let me take one more example. So push 30. So again the value of val is greater than min val. So what we have to do, we only have to push it into the stack, and then we don't have to change the value of min val. The min val will become 10 only because the minimum value of these values is 10 only. Okay, but suppose I have pushed 8. Okay, so if the val is less than min val, now something different is going to happen. Okay, so now the condition came is the value is less than min val. Then what we have to do? You might be thinking that we can directly push 8 here and we have to change the value of min val. Okay, so this is correct at this stage. Okay, in this stage this is correct, but suppose we have popped this. Okay, suppose we have popped this. Now our min val will also be changed. So what will be our min val? Min val will become 10. How can we find that this 10 value? We have not stored this. We have to do something else. Okay, because now our minimum is 10, and now we have to change this value to 10. So we have to do something in this stage so that we can retrieve our last min val value. Okay, so let me change this. Okay, so what we will do is, first I'm going to explain you what are we going to do, what and how. Just focus on these two things. So what we are going to do and how we are going to do. And when we complete this, then you can easily understand why we are doing this. Okay, so what I will do in this stage is, I'm not going to push 8 here. Okay, so what I'm going to push here, I'm going to push some encrypted value. That means some fake value. What is the fake value? I'm going to push val plus val minus min val. Okay, so in this stage, I'm going to push val plus val minus min val. That is, what is the value of val? This is our val. Okay, that is the actual value. So 8 plus 8 minus min val is 10. minus 10, that is equal to 6. Okay, so I am going to push the some fake value. So this condition is crucial. Okay, so I'm going to push the fake value. And what will be our min val? Min val will become the val, that is 8. Because now in this stage, what is our minimum value? Minimum value is 8. So we are maintaining, we have pushed the original value to the min val. Okay, so we have assigned the original value to the min val, and we are storing the fake value into the stack. Okay, so now just focus on these two, like what we are doing. Okay, so we are doing actually this, we are storing the fake value. And how we are storing? So we are just storing using this operation. Okay, and we will understand it later why we are doing this. Okay, so if I tell you why we are doing this, because we want to retrieve our last value. Okay, suppose if we are going to push this variable, if we are going to push pop that element from the stack, then we have to retrieve our last minimum value. Because now if we are going to pop this, now our min val have to be changed to 10. So that's why we are going to do this, because by using this value we are going to find this 10, and we will see how we are going to find this. Okay, so later we are going to figure out like how we are going to find this 10. So let's move further. So we have pushed it into the stack. Let's suppose we are doing the second operation, that is push 35. So now the value is greater. Okay, now the value is greater. So if the value is greater than min val, then we directly push it into the stack. Okay. So this is our, actually this is our special condition in which we have to do something different. Okay. So now again the same case is going to happen. I'm going to push 7. Now the val is less than min val. If the val is less than min val, then what we have to do? We have to store some encrypted value. And what is our encrypted value? Val plus val minus min val. So this is how we are doing our encryption. So let's do the operation 7 plus 7 minus 8. Okay, so that is equal to 6. So again we have stored some encrypted value, that is fake value. And what will be our min val? Min val will become 7 only, because we are going to store the original value in min val. Suppose we have to find our value. So where our val is stored? In min val. Okay. So this is our special condition. Now the question arrives, how we can find, like in this stage we have done the encryption. Suppose we are popping it, and how we can find it, like we have done some encryption here. So for this there is one trick. What is the trick? So I said, like when the value in stack is minimum, then when the value of stack, when the element of stack is less than min val, that means in this stage we have stored the fake value. Okay, so when the value is less than min val, that means we have stored the fake value here. You can see it, it is less than min val, and you can see here also it is less than min val. But now the question comes, like why it is always less than min val. See, so now I'm going to tell you why it is always less than. So it is our actually the value val plus val minus min val, and I said like it is always less than val. Why? So when I'm doing this operation, when our val is less than min val, okay, if our val is less than min val, then only we are going to store the encrypted value. So if val is less than min val, then this is always negative number. Okay, if val is less than min val, then it is always less than. always a negative number. If this number is negative, see, if this number is negative, then it is going to less than well, because we have to decrease something in value. Okay, that's why the whole number is always less than well. Okay, let me repeat once again. See, see, this well is always less than min well. See, 7 is always less than 8. Okay, only then only we are doing the encryption when well is less than min well. If well is less than min well, then it is always a negative number. If this is a negative number, if this is a negative number, then it will decrease this well, because we have to do the subtraction here. Because suppose this is a negative number, see, suppose this is -1, so the whole number will be always less than well. Okay, so if this is a negative number, so the whole number will always less than well. So that's why in this condition it is always less than well. So this is how we are going to represent this stage. When the value is less than min well, that means we have done some encryption in this stage. Okay, so let's go and do the push operation and min well operation. Okay, then we are going to see how we are going to pop the elements. Okay, let's go and code this. So this is our editor. First, what I'm going to do is I'm going to code the size. What is our size? Size is simply we have to return the length of data. Okay, so what will be our size? The size of stack. And now I'm going to, let me raise it here. Now I'm going to do the minimum value. So how we are going to return the minimum value? So if self dot size is equal to 0, that means our stack is empty. Then what we have to do? We have to return -1 here, and before -1 we have to print it. What? Stack underflow. Okay, so this is what we have to do. That's what we have to do. That means there are some minimum value, okay, or there are some element in the stack. So in that case, we simply have to return the minimum value, because we are maintaining our min value in every stage. Okay, so this is completed. Now we are going to solve the push method. Okay, so if self dot size is empty, that means if our stack is empty, then what we have to do? We have to self not size dot self dot data dot append. We have to append the val into the stack. And what else what we have to do? We have to update our min val value. So self dot min val will become val. Okay, so when our stack is empty, then we have to push that element into the stack, and we also have to assign the min val value. That's it. What will be our second condition? If val is less than, self dot min val. If value is less than minimum value, that means we have to do the encryption. Okay, we have to do the encryption at this stage. Else we don't have to do any encryption. No encryption. Okay, if we don't have to do any encryption, what we will do? That we don't have to change the min val value, so we just directly push it into the stack. So self dot data dot append val. Okay, so this is easy. But what we have to do? We have to encrypt the value and we have to push it into the stack. So let's push it. Self dot data dot append, and what is the value which we are going to store in the stack? Val plus val minus self dot min val. Okay, so this is our fake value which we are going to store. And The next value which we are going to store is, I'm going to update our min-val to the val. Okay, see this. In this stage, what we are going to do? First, we are pushing the fake value, and then we are going to update our min-val value with the val. So this we have done. Now we are having the two more functions, pop and pop. So let's discuss how we can do these. Okay, so let me erase this much. So suppose if we are going to pop it, let me do one more operation, that is push 28. So we just directly push it into the stack and min-val will become same. See, suppose we are going to pop it. Okay, so if we want to pop this, if the top value is greater than the min-val value, that means this is our original value. Okay, so in that case, our min-val value will not be changed, because we are not popping the seventh value. Okay, we are going to pop the 28. So if the stack top value, if the top of a stack is greater than the min val, then this is not the encrypted value. So we directly push it, pop it. We directly pop the value. Okay. So in this case, we know, like we directly have to pop it. But if we want to pop it now, that means if we want to pop 7 from the stack, then see how we are going to pop it. Okay, so if we want to pop 7, then first what we have to return? We have to return 7. That means this value. Okay, and we have to pop this. So we will directly pop it. We have to change the value. So we want to now retrieve our 8. So how we can do this? See, this is our fake value. Fake value is val plus val minus min val. Okay, this is our fake value. So what I will do is, see, if you subtract this value, 2 into val minus val plus val minus min val. If you subtract this value, then what you are going to find? You are going to find this min val. Okay, and what is our val? We have actually stored this val value into the min val. So this is our current min val, and we have to find our last min val. Okay, so this is our last min val. So we have to find this value. Okay, and what is this value? This value is actually our current min val. Okay, so what I will do is, I'm going to store a val into I'm going to store the val. So I will use a min val value, which was this. Okay, so this is our actual val. So when I will subtract this, see, let me solve this condition. It will become val minus val plus min val, and these two conditions will subtract, cancel to each other, and in the end we can easily find our min val, that is 8. So what we are going to do is, we are just directly subtract 2 val with the fake value, and then we can easily find our min val. Let's do this. Okay, so let me do this. Okay, so 2 val minus this value, that is fake value. Okay, so what is the value of val which is stored in min val? That is 7. 2 into 7 minus what is our fake value? That is 6. So if we solve this equation, 14 minus 6, that is equal to 8. So this is what we want. Okay, and this is the reason for why we are doing this. Okay, now I think you are clear about this, like why we are doing all this. Okay, so this is how we are going to retrieve our last min val value. Okay, and this is we will retrieve it. So let's do and code this. Okay, so first I'm going to code the top value. So for finding the top value, first I have to find it whether this is our fake value or this is our actual value. So I will use first this condition, self dot size I will just handle this edge cases is equal to 0. That means there is no value in the stack, so I have to return -1, and before returning the -1 I also have to print the stack underflow. Okay, and then I will find it whether we are having the actual value in the top of stack or the fake value in the top stack. So if self dot data -1, that is the top value, is less than self dot minval, if this holds true, that means we are having the fake value. In this stage we are having the fake value. Else, if this top value is greater than the minval value, then we are having the actual value. So in case of actual value, we just directly return self dot data dot peak, that is topmost value, and we can find topmost value by -1 index. And what is our actually fake value? So we have stored our actual value in minval. In this stage, let me show it here. So in this stage, what is our top value? Our top value is 7, which we have stored in minval. So let me directly return the self dot minval. Okay, so this is easy. So let me copy these condition, and now we are going to solve our pop operation. Okay, so let me remove it. So instead of when we are having the actual value, like when we are having the actual value, we are directly popping it and returning it. So let me just simply write data dot pop, and I'm going to return it, which we are doing now. What we are going to do in case of fake value? So first I'm going to store the fake value, that is self dot data dot pop. How I'm storing? I'm going to pop this value and I'm going to store in the fake value variable. Okay, so we have stored it into the fake value, and then what we have to do, we have to find our val, which is our actual value, that is 7. So we are going to find 7, which we have stored in minval. So this is our current minval, self dot minval. Okay, then what we have to do, we have to change our minval, because now we are popping this value 7. So now our minval will become 8. So how we can find it? 2 into val minus fake value. So let me do this. So we have to change our minval value to self dot minval is equal to, what I'm going to do, I'm going to subtract with 2val minus fake value. So from this operation we can easily find our last minval value, that is 8. Okay, then what we have to return, we have to return our val, that returned value, that in this case we have to return the 7. Okay, so this is what we are doing. So I think I have covered all the operations. Let me run it, and it is accepted. So let me submit it, and all the test cases are running absolutely fine. So guys, thank you for watching this video, and we'll meet you in the next video. Until bye bye.